You've got regions, you've got places. I had a good look through this last night. One of the things I found in here were bridges. There are bridges that cross the Yarra River, and so we have triples in here somewhere, take my word for it, which say crossed by, or has crossing, and then the URI of a bridge, and all the bridges that cross the Yarra. And so, if for instance, if we, and there's stuff here in all kinds of different languages. Here we go, crosses. So these are all various bridges, and if we look at, say, Princess Bridge, click on that. And so this is what I was saying about linked open data and how it actually enables this kind of exploratory style. You can just browse around it. Okay, these are just web pages in a sense, but although what we're seeing here is an HTML page, underlying this is RDF. And if you, because we're accessing it through a browser, the server knows to send us HTML. But if we had requested RDF, when I'd clicked that, I could have sent a request saying, give this information to me in RDF form, and it would have given me a document in RDF XML, or in Turtle, or in one of the other RDF formats, which would be useful for a machine. So if I'm writing software that's consuming this, I can send a slightly different request to that same URI and retrieve this data in an XML form. Okay, so that's back to the. So that's an example of a linked open data store. How do I do this? Resume slideshow. Okay. So I'm just going to show you next, another few minutes probably, a few queries where we're going to be looking at some of that data using the SPARQL query language. Now SPARQL, has anyone here used SQL? Does anyone know? We've got some, okay, some people who know, yes, some people who know SQL, and I would imagine that there's a few people here who are kind of, if not know SQL, at least have a passing acquaintance with SQL.
But the query language,
yes.
in the sense that it's how you actually send a request for information to a data set.
Yeah, to a relational database. And SPARQL is basically the equivalent of SQL for RDF databases. It's actually derived from SQL. It's been designed to actually be quite familiar. If you know SQL, you can learn SPARQL quite easily. I'm going to show you a few SPARQL queries, and I hope you will actually be able to follow along, even if you're not going to go away and write one straight away. But I think that's not too much to ask. Actually, it's quite a simple query language. So what we're going to do is use this website called sparklebin.com to get some data from Wikipedia and show you how to turn that into a map and display it on Google Maps. So SPARQLebin is a website where you can enter a SPARQL query, and you can enter the URL of a SPARQL server. So we can say, send this query off to Wikipedia, to DBpedia, and then you press the execute button, so query gets sent off, and it returns your results. You can click on this if you like, but I'm just going to, we don't have a lot of time to do this, so I'm just going to step through it. But feel free to follow along if you like. If you can type this hugely long URL. Okay, so this is the first of the three queries I'm going to show. This one is called a describe query, and it's basically saying, tell me everything you know about this resource. So what we're saying is, first we have this, the first line says prefix, RDFS, and then the URI. That's an identifier of an ontology. Okay, so RDFS we're saying is a code, effectively the name of an ontology, which is RDF schema, it's a vocabulary which contains terms that are kind of quite common, standard RDF type terms, including the one we're using here. If you can follow my mouse, can I see my mouse? Yeah, RDFS label. A very common thing, of course, is that things have labels or names. And so what we're saying here is describe a river where the river's label is Yarra River. So effectively we're searching for the thing called Yarra River, and that @en says in English. Now we could have actually searched for it by name in some other language if we'd specified a different language code. So if I click on this, here's one I prepared earlier. Okay. Okay, so here's our query, and I can go down to the execute button and results. Okay, so this is, and you notice we've got here S, P, and O, subject, predicate, and object. That's what they stand for. So these are all the triples which have something to do with the Yarra River. So here we go, the Yarra River has has a mouth, which is a discharge location. Yeah, I don't pretend to understand that, but you know, some of this we'll find here some bridges in here. But so there's actually a lot of information about the Yarra in Wikipedia. You'd be surprised. A lot of structured information. So back to the slideshow. Okay, what bridges cross the Yarra? So here what we're saying is, notice I've defined a new prefix here. Ah, bollocks. Let me go back. Okay, I've defined a new prefix here, prop, which is a DBpedia property. Okay, so an ontology used by DBpedia, because I want to ask a question about which involves a term drawn from that ontology, which is crosses. Okay, it's part of their terminology for describing how bridges and rivers relate. Instead of, whereas in the previous query I had describe, here I'm saying select. So I'm saying select bridge where bridge crosses the Yarra, and Yarra is the thing called Yarra River in English. So this should give me a list of the URIs of all the bridges that cross the Yarra. Okay, if I press the execute button. Okay, so these, as you can see, these are all the URIs of bridges that cross the river. Moving right along, that's my final query. Now we're getting tricky. Show us names, pictures, and geographic locations of all the bridges that cross the Yarra River. So here we've got, I'm selecting name, picture, latitude and longitude, where bridge has geographic latitude. So what I'm saying here is name, picture, latitude and longitude are, if you like, columns in my results. Those are the results I'm after. And I'm saying the latitude is the thing which is the geolat of bridge. And geo is a geospatial ontology, which I'm referencing up here. Okay, this is the geospatial ontology, and that's some geospatial datum. So, okay, I'm after the latitude and the longitude of the bridge's name, the depiction from this FOF vocabulary, which is a friend of a friend vocabulary used for social networking, of the bridge that crosses the Yarra, and the Yarra is the thing that's called Yarra River in English. So, run that. So, but if you look at this, I mean, this query is not hard to understand. Even for people who aren't familiar with the SPARQL query language, it's pretty obvious. And if you have someone on hand who is familiar with it, it's the kind of thing that you can easily communicate, a query with them. So if I click the execute button here, we should retrieve a table of, okay, there's the Prince's Bridge, there's a picture of the Prince's Bridge, there's its latitude and longitude. Okay. So now finally, this is what I was working on last night. So here's our results, and plotting it on a map. If you copy and paste that straight out of that web page into a spreadsheet, which is what I did last night, save it, you go to Google Docs and you go create new Fusion table. And a Fusion table in Google Docs, if you haven't used it, it's like a Google spreadsheet, but it has some extra features where you can make visualizations of it conveniently. But it's really just a spreadsheet. So you just paste that table of results into the Fusion tables, and you click a button saying map, visualize as map, and it does your map. It's dead easy. I was super impressed. And I've actually got, I can show you I'll show you the results of that. So this is the Fusion table. And as you can see, I mean, what I did was I just pasted that in, and it converted the URLs to pictures. It recognised them as the URLs of pictures, and it's actually put little thumbnails of the pictures in, which is really nice. And so you can click on these. I think you can click on that. Okay, maybe you can't click on that. But the other thing you can do then is just click on this map, and it recognises that those columns called latitude and longitude, it must, it's pretty smart. It knows what latitude and longitude mean. And so it produces this map. Is it still loading? Oh yeah, you can see these red dots here. With the Bolt Bridge. So that's, and literally I had not used Google Fusion tables at all until last night when I was, what can I do with this lovely SPARQL query result? And I Googled, how to make a Google map, and this came up 20 minutes later. I posted this on my Facebook page. So it's pretty dead easy to do. And I think what we should be aiming to do in the Honey project is basically to provide that similar level of flexibility where people can easily go from a query that they can express ideally in some graphical form, by dragging and dropping and clicking on buttons, and then going to a thing where they can produce a map or some other kind of visualization.